Hello and welcome to Forbest Academy. Welcome to week 3 of our AMC 10-12 problem breakdown videos. This week we're going to be looking at 5 AMC 10 questions, past paper questions, which we are going to be breaking down and looking at the concepts required to answer these questions. So we're going to start off this week with this question here. 6 points are equally spaced around a circle of radius 1. Three of these points are the vertices of a triangle that is neither equilateral nor isosceles. What is the area of this triangle? Okay, so the first thing we want to do with a question like this is to draw ourselves a quick diagram, because it's very difficult to try and imagine this. So let's draw ourselves a diagram and see what we've got. So we've got a circle and we've got 6 points equally spaced around this circle. So this is going to look roughly like this, and we should be able to spot, although I've not drawn this fantastically well, we should be able to spot that actually what we've created here is a little bit of a hexagon. If we joined all of these points up, we would get a hexagon. And as we know from some of our previous videos, a hexagon is made up of 6 equilateral triangles. So that gives us a nice bit of information going forward on what our triangles are going to look like. So first things first, we need to create ourselves a triangle using these points that is neither equilateral nor an isosceles. So from this point here, we need to look at where we can draw our triangle. So I'm going to create this triangle here. We can tell that it's not an equilateral triangle and it is not an isosceles triangle. If you look at the other options available, we couldn't go here because even though I've not drawn it particularly well, this would be an isosceles triangle. In the same way, we couldn't make a triangle here because that would be an equilateral triangle. So our only option here of a triangle that is not equilateral and not isosceles is this triangle here. Now we know that the radius of our circle is 1, and this line here is the diameter, so that must have a length of 2. We should also recognize from our circle theorems that when we circumvent a point on the circumference from the diameter, that will always form a right angle. Remember that a point on the circumference in a semicircle will always form a right angle. So we have a right angle there, and we also know this length at the top here, because as we said before, we've got an isosceles triangle from this, an equilateral triangle from the hexagon we created. So all of these sides must be equal to the radius. So all of those sides must be 1. So therefore, this final side of our triangle must also be 1. So we have a right angle triangle with sides 1 and 2, 2 being our hypotenuse. So if we want to find our smaller side here, we're going to use some Pythagoras. So a squared plus b squared equals c squared. So the square of the 2 smaller sides is equal to the square of the hypotenuse. The hypotenuse is 2, one of our smaller sides is 1. So therefore, if we rearrange this, c squared minus a squared is equal to b squared. 2 squared is 4, minus 1 squared is 1, equals 3. So if b squared equals 3, b must equal the square root of 3. Okay, so now we have all of the sides to our triangle. Let's look at finding the area of this one. Well, we have a right angle here, so therefore we can use 1 and root 3 as the height and the base of our triangle. So half base times height. So half base times height. And in this case, that is going to be half of 1 times root 3. Which gives us the answer of root 3 over 2. And that is our answer B of our multiple choices. So our key points here are forming that circle, recognizing that 6 points equally split around our circle will form a hexagon, and a hexagon can be broken up into 6 isosceles triangles. Our other key point is realizing that when we split our circle in half, any triangle we create on the circumference will form a right angle. Any triangle within a semicircle will form a right angle, and then using Pythagoras to find those missing sides. Thank you very much for watching this video. Please come back again tomorrow to watch our day 2 video this week of the AMC 10 past paper questions. And please like and subscribe this channel. Thank you very much for watching, and I look forward to seeing you again tomorrow.